Is it back to me again?
You or me or?
I don't mind. I'll do
I
it.
guess I can.
Okay, you go ahead, Maria.
All right, dear Heavenly Father, we'd like to thank Thee for the opportunity we have to meet together and go over these questions. And we pray that we may have Thy Spirit to go with us, to open our minds and help us understand the things that we are learning. And we'll be able to have a good week. And we say these things in the name of Thy Son, Jesus Christ. Amen.
Amen.
All right. Okay. So we've got the T-distribution applet and the other data A1 and B1.
Mm-hmm.
Okay, so information. Use the following information for the next two questions. Good gravy. Suppose we have a set of paired data and let D equals X after minus X before. The null hypothesis is HO mean D equals 0. The alternative hypothesis is the HA mean D does not equal 0. And the population standard deviation sigma is not known. Jordan collects a sample of sizes n equals 9 and computes D, and I think that's the sample mean, D with the line over it, equals 2.2, and SD, sample standard deviation, is 3.3, equals 3.3. What is the value of the test? Well, can't talk and put it in at the same time. Hold on.
Yeah, I need to probably do this on my other computer.
9. Okay. Standard deviation is 3.3. And the sample mean is 2.2. Okay. What is the value of the statistics? Let's see. Value.
Oh,
Not equal to. Are we using a 95% confidence level, or are we using nothing? Hypothesis is 0. Okay. The T. What is the value? Are they asking for the T value?
I think so.
Test statistic, yeah.
Is that what you guys got?
Is D. I have 2.
Yeah, I got 2.
Did we just put in 2 and no zeros or anything? Just 2?
But well, it says round to 3 decimals. In the instructions up there, it says.
Okay, 2.000.
I don't know if you need to put the 0.000, but hopefully that won't hurt.
Okay, alrighty.
I'll just put 2 and see what happens. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
I'm sorry, isn't the p-value the 0.04?
Yeah, I think so. Isn't it?
Yeah, because I mean, if you put it greater than, it comes up as 0.04025, so 0.03. Weird.
Yeah, I'm pretty sure that is the p-value. I think that's right.
We'll find out. Interesting. Okay.
Oh, but we're supposed to round to 3 decimals, so it's just
Right.
0.4.
So the D being 2.2 and the S to the D being 3.3, are we supposed to type it in somewhere?
Well, I used the same quantitative inference chart that we used last chapter and put it in the summary statistics.
On
I
the
went to the
The paired sample t-test? Oh, the mean being 2.2 and the standard deviation being 3.3.
And 9 for the population there.
I put 9
The
in
number.
there.
Okay, and then we got 2.000 for t, and then we've got for the p-value though 0.040. So it only wants 3.
Yeah.
So 0.040.
Yeah.
Okay. Fine, I'll quit fighting it.
All right.
Alright.
So what do we do for 4? I don't like going, huh? What is the probability?
Use this probability.
So if you type in all those numbers in the Excel sheet, it has
Right.
a little box that says p-value, and it tells you what the.
0.0805.
But you
Yeah,
gotta
great.
make sure your type of test is greater than, because it said the probability of obtaining a test statistic greater than Jordan's test. So if you change that to greater than, the p-value will go to 0.040.
Oh, to greater than.
All righty. Ready for number 5?
I know. Yeah.
Okay. Use the data file to answer the next 6 questions. Perform a paired sample t-test in SPSS. Be sure that the test group 1 minus group 2 use null hypothesis of sorry, I forget what the D is again. But
D with the line over is sample mean.
oh, it's just too small on my screen to see the line over it. Okay. Use the null hypothesis of the sample mean equals 0 and alternative hypothesis of sample mean does not equal 0. And a significance level, or a level of significance of alpha equals 0.10.
So that's 90%, isn't it?
What's that?
So that if it's 0.10, wouldn't that be 90%?
Yeah. Okay, so 5. What is the test statistic? Round to 3 decimal places. Now, I don't have SPSS. I didn't even know where to get that. I haven't even seen it yet.
Hey, when I asked the teacher or somewhere I'd asked about that, and I was told we wouldn't be using it, we'd be using Excel.
Yeah, we're using Excel.
Okay, so are we just using it on that quantitative?
Yeah.
Okay.
So we're just plugging in the value 1, variable 2.
Differences.
Yeah.
Alrighty.
And so plugging in all those numbers, and then I got to plug in these other ones.
I got 2.
Again, yeah. 0.000. Again.
0. And this was a does not equal. And the significance being 0.1, so it'd be 0.9 instead of 0.95.
Right. Oh, I guess I better get rid of these statistics up on top. There we go. That makes it.
So I just realized I needed to delete those.
That's why it was the same.
Yeah, because I was looking at it and it was like variable 1, 20, variable 2, 20. Difference is 9. I'm like, how does that work?
407, is
Not
that?
very effectively.
Yeah. So I got it now.
I have 0.446. Does that sound right?
As what?
0.446 for the test value?
I got 0.407.
Yeah, I got 0.407 as well.
Because I have the N is 24, confidence level is 0.9. Because
N?
it has the,
And
That
it's
should be
20.
20. Right?
20, maybe that's, because I started at 5 and I went down to 24. All right, let me change that. So 0.407.
Yep.
That sounds better. That's why I like doing this, all of us together, right?
Yeah. More brains.
Helps for sure.
So, what is the p-value?
0.689.
689.
That's what I have.
Yep. Okay.
What is the correct decision based on this evidence?
P is low, reject the null, but it is, isn't it? Because we're using the 0.10,
Yeah.
so it's lower than that, right?
So we would,
No, it's
No, it's higher than that.
because it was 0.1.
Yeah. So,
0.689 is higher than 0.1. So.
yeah. So we're going to fail to reject it then.
Yep. Hey, you're
Right.
if the P is low, reject reject the null as genius. I love it.
Oh, yeah, that came off a video.
I obviously didn't watch it.
Oh. Yeah, I made myself a little card.
Yeah, I
And then
remember
still got
hearing
wrong on the
that.
quiz, so well, I got it right, but I got it wrong. They said, no, reject the null. Yeah.
I know, I got myself mixed up on that slightly still. Like I need to go through all that again.
I did too.
Okay.
And then I missed the first one twice, and I'm still like going, okay, what in the world? Let me go back and refigure that one out too. And the rest I was good on the second time.
Okay, so what, question 8? Is that where we are?
Yeah.
Yeah, we're on 8.
Okay. So suppose the alternative hypothesis is instead greater than 0. What is the correct
All right.
decision based on this evidence?
That makes my p-value 0.344, so it's still not good enough.
Right.
So what would be the second one?
That's what I think it
Sufficient
would be.
evidence.
Don't we have sufficient evidence? I saw that somewhere.
The last two have sufficient evidence that it's greater than 0.
Oh, it was on a.
I would go with the third answer, right? No?
Oh, well, if we have evidence that the mean is different or greater than 0, then that means we rejected the null, right?
Right. Oh,
So
wait. If it's greater than 0?
I don't know. I'm gonna,
Sorry. No, sorry, I was thinking p-value and stuff again, so.
Well, the p-value would be 0.344, which is still greater than 0.1.
Right.
And it seems like we would have sufficient evidence that the mean of the difference is greater than 0 still. No?
I have this. I have it.
See, I think this is part of what got me on the last quiz too. It's like you have to analyze each sentence so carefully.
Right.
There it is. Okay, state the conclusion in layman's term. If we reject the hypothesis, we have sufficient evidence to say. If we don't reject it, we have insufficient evidence. So,
But we're
reject-
rejecting?
We failed to reject, or did we reject? What was it?
We failed to reject.
If we fail to reject, if we don't, so that's the same as we don't reject it? I'm so confused.
The P is low, reject the null. The P is not null, therefore we do not reject the null.
So we failed to reject it, so it's insufficient evidence.
That's what I thought. So I thought it was the second one as well.
Yeah. I think that's what it says.
I'll go with that.
I printed out, let's see if maybe you guys can understand this. I printed out the PowerPoint
PowerPoint?
where it said
Right.
that down here, but I'm confused as to which one it is.
Yeah.
And you probably can't see it because it's probably all wiggly.
We got part of it.
Anyway, it says if reject the hypothesis, we have sufficient. If don't reject hypothesis, we have insufficient. So we failed to reject, so we have insufficient.
Well, we got 2 shots.
Yeah,
So we'll go with the second one and
if it's wrong,
all right, we'll go with that second one for, I think 2 of you said yes.
okay, here it goes. P-value greater than the alpha, don't reject hypothesis. Example, 0.072 is greater than 0.05. Therefore, we don't reject the hypothesis. We have insufficient evidence to say that the height of fathers and sons are different. I don't know if that helped or not. So,
Yeah, I think we got it,
moving on.
hopefully.
Yeah, well. So now we're doing the next one. Chapter 12, data B1. B1. Okay.
All right, so on
Oh, no.
this next one, use a data file to enter. Be sure that test group 1 minus 2 data comes from blah, blah, blah. The null hypothesis is 0. The alternative hypothesis is not equal to 0. And the significance, level of significance is 0.01. So we still have a 0.09, 22 items.
Oh, well, now we got a 0.99 confidence level instead of a 0.9, right?
Oh, because it's 0.01. Yes,
Instead of
you're right.
0.1.
0.99. And then it's not equal. So number 9, what is greater, n or df? And n would be greater because the df is n minus 1.
True.
Yep. So it doesn't.
That was easy. I like that question.
That was a good one.
Question 10. What is the p-value? Round to 3 decimal places. And let me enter all this in here. Copy and paste. We're on 12B now, right? I can close this 12A.
Yeah.
Yes.
I got so many Excel files open, it's sick.
Unless it does something mean and tells us to go back to it.
Yeah, right?
Right.
And that'll be my luck.
Or we did it wrong and then you got to go back and make some corrections and put it in again.
Right.
You might have it shown on the bottom where you can just click to open it back up.
Okay, paste. And they're asking for p-value?
Uh-huh.
Right.
All right, p-value, it looks like it is. Sorry, I'm mixing up all my screens here. Hang on just a sec. Okay, is it 21 point, or no. I got 8.455.
I didn't get that.
I didn't get that.
How many?
Yeah.
How many?
Oh,
What number?
I just have, never mind. It looks like I just have group 1 in there.
Oh,
Sorry, the Excel is really screwy with me. Okay, so here's my question. If we have two data groups, how do you enter them all into the quantitative?
On the
We're
second
using
tab, the
quantitative
paired
difference.
sample.
Yeah, you're on
Right?
the paired sample,
Yeah.
tab over.
Oh, that's what it is. I'm
Quantitative.
not on paired sample. Okay. Gotcha. Okay.
Then you have to have the differences.
Right. Copy, paste. Got it. Okay, it looks like the p-value is 0.001. Does that
So I
sound
That's what I
right?
have.
Yep, that's
Okay.
what I got.
Sorry about all that, guys.
You're good. What decision do you make? Reject that thing.
That's
Done.
right. It's slow. It goes.
I got that one. All right.
All right. Okay, you decide to try another alternative hypothesis. This time you use greater than 0. And you keep the same level of significance. Did the p-value increase or decrease? I wasn't paying attention. I think it
It decreased.
yes, it did.
So we still reject it.
Yes.
Yep.
Cool.
That was simple, huh?
Question, boom, boom, gone. Okay.
All right. So based on your response from the previous question, what conclusion do you make? We have insufficient evidence that there is.
This one would be sufficient, right? Since we went with insufficient when we rejected it.
That's what I would say.
Yeah, I think so.
So it's either 1 or 3.
No, well, no mean difference, or there probably no mean difference because there's not a whole lot of difference between the two. They're fractional.
True story.
1. Is that
I
what
would-
we're going
I would.
But I could be wrong. What do you think, Aaron?
Yeah, say I also got a D on the last quiz, so.
I mean, that sounds good to me. I can't remember which one it is, but one sounds good to me.
Try it.
I have more to go.
Alrighty. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Huh.
Would it be greater than?
That's what I'm leaning towards is the greater than for my answer.
Yeah, 'cause greater than was less.
I think so.
Right.
Okay.
Yep.
All right, determine a 95% confidence interval for the mean difference between the two groups. Put your answers below.
All right. This is a part that I was messing up last time on the quiz. I was like, point estimate, blah, blah, blah. What?
But this is the difference, right?
Goodness gracious, I don't remember. Is it?
I'm looking.
Yeah, I need to look too.
I can't remember this one.
I need to go over all those videos again.
Yeah, I hit that.
Sample mean, X bar is sample mean or the point estimate. So would that be the 11.955? 11.955?
That's the difference for sure.
Is that the X bar? That mean the difference?
That I don't know. Let me look. I have my notes here somewhere.
Sorry, say what you said again.
I said, isn't it the 11.955 because the sample mean or point estimate is the X bar?
Yeah,
That's
the mean, right? I think you're right.
Yeah.
a single value given as an estimate of a parameter of a
You're right.
population.
Well, that's weird. Why the heck did it ask us to give the point as? Oh, because it's later questions. Okay.
Okay.
So you were saying that was the 11.955.
I think so.
Yeah, I think you're right.
I do too.
Margin of error. This is the one I got.
This is the one I messed up on.
Yes. There we go. Margin of error is the T, parentheses, S, right there. The bottom one.
Oh, hold on. I gotta go back where I can see pictures. Oh, T times the S divided by square root of N. Is that on here somewhere?
Margin of error. So you're going to take your confidence level and you're going to subtract your T. Oh, am I right? I think that's how you do that.
Is that really how simple it is?
I think that's how you do it, isn't it?
Oh my goodness.
You take the 18.607 and you subtract the 3.737, and it gives you your margin of error.
18.
That's your confidence interval. That's the upper level.
Oh, 18 there.
607, the upper confidence level, subtract the T value gives you 14.870. That's your margin of error, I believe.
Confidence level? Isn't confidence level just 0.95?
Your confidence interval, I think, is what you're using for that margin of error.
Oh, okay.
And you can use the upper or the lower, but I think if you use the upper, you come up with a positive, and lower, you come up with a negative. But I think that if you take that upper confidence interval of 18.607 and subtract this 3.737, you get the margin of error. And this is the one I went over with the teacher this morning, and I thought that I understood it. So we'll see if I, because we were breaking up really bad, but I think I understood it. I thought. I could be wrong. Margin of error is really hard for me.
Yeah, it was for me too for some reason.
Me too, for sure.
I think that that's how that works.
So it's just the confidence interval minus T?
I
Which
think
would
so.
be the 14.87.
Well, that's what I've got. 14.870, round to 3, right?
Right.
Well, that's what I got. But so if it's wrong, you guys.
There will be no crucifixions.
Well, if I do the one cell minus the other cell, it actually gives me 14.869. But if I just do the numbers that show up, then I get 14.87.
Huh.
I wonder if it'll give it to us either way.
That's what well, we could try both ways and see what happens.
Yes, we can.
It's still supposed to be on greater than, though, I guess is the question.
We did have
good
it.
call. I'm still on not equal to.
I have mine on greater than.
I have mine on greater than.
Well, hopefully they would give us both. So we'll go with the 14.87.
Does that change if we change this?
And the next one is just input the lower bound.
Change if you change the greater than, less than, or equal to. The numbers on the bottom didn't change, so.
The next two questions are just putting in the upper bound and lower bound.
Okay. Okay. 14.870 is not correct. Don't submit.
Too late.
And question 15 is not right. 17 or 15.
What? How is that
Yeah.
not right? I don't understand that.
Oh, and
Well,
Oh, you know what?
14
I don't know if 15 has to do with any of the questions before. I bet you that question stands on its own.
Oh,
possibly.
So, you
It
think
says, as we have
information?
seen.
Well, I think that as we have seen is for that first sentence, and then in general, which alternative hypothesis will give the smallest p-value, and that's not enough information. It depends on the problem.
yeah. So we don't have enough information.
Oh man, we just didn't read that question right.
Yeah. And 14
All
got
right.
14 wrong too.
All right, we got to figure that one out.
We said we had sufficient, so we don't have sufficient. We have insufficient.
Oh, I clicked the third answer, and that was right.
Okay. Yeah, thanks.
I forgot to change it back to the first one, so I guess that's good.
That's good. So there was sufficient evidence that there is a mean difference between the two groups. Okay.
All right, then we just got to figure out this margin of error thing, which I have such a hard time with that.
The margin of error.
Yeah, the margin of error is wrong. I was bad. I didn't get it, I guess.
And I put 14.870 just in case,
It's not right.
and that didn't work either.
All right, let's go look at margin of error.
Mm-hmm. How to do margin of
Oh,
error.
this is what killed me on the quiz too. I just couldn't figure it out.
Yeah.
I thought I had it, but
Back to the quiz.
turns out I didn't.
See, and then the margin of error on the quiz, homework quiz, was the upper band minus the X bar, which was 1.107 in that case, equal to 1.945. And that was the right answer.
Yeah, I don't know.
I give. Surrender. I don't know. I thought I had it. Hopefully she's listening and we've recorded this and she will give us help.
Let's see. Help
Well,
us, struggling.
margin of error.
That parking lot is used for a lot of interesting things. I wouldn't be surprised. You never know, but we keep an eye out.
95% confidence interval with a 4% margin of error means that your statistics will be within 4 percentage points of the real population value. The margin of error can be calculated in two ways. Margin of error equals critical value times the standard deviation. Critical value times standard deviation.
Oh, I'd love to be there for you, my brother.
Maybe instead of a divided by. Okay, so what's our critical value?
November 5th. It's the it'll be the first Sunday of November.
T is the critical.
Right. So we got 2 weeks that are going to be free. This Sunday is the next Sunday and the following.
Our T is our critical value.
Yeah.
So we multiply T times our sample or whatever deviation or SD or whatever it is.
Right?
Can we just use the equation that they gave us in chapter 10, but replace?
We're not gonna
Yeah.
be using the.
I would think so, yeah.
So,
So I made an Excel sheet for that, and if I punch in all those numbers,
it still in the works. We still don't have a complete, thing yet from it. The bishop may be going over a little bit of that Sunday, so you'll have to take notes for me. So. Other than that, I may try to get together with everybody Wednesday night if we can, to do a friendly meeting before I leave, just to kind of bring Alex up to speed and some other things. So I'll let you guys know tomorrow. Thursday afternoon.
So it'd be our T times our,
Right. You know, I come across with some very interesting things that I'm fucking like, it's hard to say. I've come across some fogged up windows, so I just, you know, whatever, you know.
3.3
I don't
number
want to interrupt the
10.
matchmaking. Not really, no, it's actually public property.
I have a feeling this should be really easy, and I,
As
Yeah.
long as they're not doing anything to, as long as they're not trying to break in.
'Cause the sample means a normal
Trying to
run.
break in or something, but, yeah.
Mu and standard deviation divided by the square root of n.
No, they're not, as long as they're not causing any.
But we
trouble,
don't have a
they're not
known
necessarily
standard
fine.
deviation. We have a,
But you know what, that's very good, preventative for you, that was good. You're doing good, brother.
I mean, could you just use
Yes,
the?
doing good. President, I like how President closed it up there. That was good. He was on fire. And he does too, especially in the occupation that he has. He is on fire. So are we. We're going in the right direction.
confidence interval is actually a point estimate of the X bar plus or minus the margin of error.
Right.
Margin of error is 2,
Sorry.
whatever that square, that sigma over the square root of n.
We can always try the. Hey,
Use
there you go.
m equals 2.
I need some butter.
Our confidence interval could be written as that, but we're looking for margin of error. Point estimate minus margin of error.
I was gonna say you want to take that. Very.
So their margin of error is 2 times the, what do you call that symbol?
the sigma or the alpha?
Not the alpha. I think it's the sigma. Like the circle with the line on top to
Sigma.
the right.
That's sigma.
Okay, 2 sigma divided by the square root of n. So 2 times whatever sigma is divided by the square root of n. Oh, well, we know what n is.
N is 22.
Right. So
And
we know-
isn't the 2 actually 1.96? Because
Is
that
it or is it
using 2 as an approximation when that's just the confidence interval is where that 2 goes, right?
where we use,
2 on each side, 95%. 2 deviations off each side.
yeah, otherwise we might have a known number to use instead of just a number 2. Otherwise we'd use 2.
So
But that 2 is a 95% confidence level is 1.6 or 96, isn't it?
right,
Something
1.96.
like that, yeah.
So then we'd do 1.96 times the sigma, which would be
The standard deviation 15.003.
Pull it up.
yeah 15.003 divided by the square root of 22.
22,
You know how hard
right.
it is to set that. I thought you were paying attention.
What'd you guys get for that?
They're not going to be listening to me again.
I'm working on it.
Did you plug it in your system there, Aaron?
Yeah, I got 6.27. I just have no confidence if it's right or not.
Uh-huh. Have you submitted your quiz yet?
No, I haven't resubmitted it to see if it's right.
Oh,
I
you
have submitted it the first time, yeah.
first time, okay.
Okay, hold on. I have 6.269.
So 6.27.
Yeah, 6.27.
Are we supposed to round it up?
Oh,
Oh, it is supposed to
How
be around
many?
3.
So it's
So-
269, right?
6.9. Yeah,
Yeah,
let's try that.
that's what I got.
Hold on, and I'll tell you.
I gotta go back in and pull it up again.
Okay. It is done. It is done. Use your Casey's.
All right, I got number
Casey's,
4
it is
wrong.
done.
You had 0.040.
I put 0.040, but it was wrong on number 4.
Oh, yeah, I got that wrong too.
Okay,
I didn't even notice that.
I didn't notice it either, so.
So far, let me see. I still have number 17 wrong.
So it's not 6.269.
I wonder if we had to multiply by 2. I don't know, I'm at 90%, so I'm feeling kind of good about 90% right about now.
Zach, have you submitted one yet?
What's that?
Have you submitted one yet?
Yeah, and I've gotten 3 wrong on it.
What?
Did you get 17 wrong?
Yes, I did.
Okay.
In fact, that's the one I'm working on right now.
I think we're all gonna get that.
I wonder if we had to use the 2 instead, or instead of the assumption 1.96.
Yeah.
Or is it because we were at a 95%, we just went ahead with the 1.96?
I think I had just gotten my formula wrong on that. And if I'm understanding it right, to find the margin of error, it's t times standard deviation over square root of your number, right?
Well, we thought so.
Well, somewhere,
I don't know.
something like that. Yeah, t times. But my number didn't come out
Margin of error,
right.
t
So.
times standard deviation over n. Yeah, that's what it is. So it's 3, not 196. It's 3.737
Right.
times
15.003. Is that it?
15.003 divided by 4.69, which is the square root of 22. So that's 3.199. So if you have 3.737 times 3.199, you get
11.95. Yeah.
How'd you guys get that?
What's right there in the mean thing?
We got that by doing our t times the standard deviation over the square root of n, which when you look at the numbers, our t is 3.737, and we multiply that by the 15.003, and then we divide that by the square root of 22.
Okay. Let's go with that.
What did we get for 4? We got 4 wrong.
Yeah. That's another one I don't know then.
What did you get for 4 on the first test?
The first time around when we did it, we calculated 0.040,
Yeah.
and I was kind of going, I'm not sure or have a clue about that one.
I
Okay.
think I.
Well, you know, it
About
says
that,
right
right?
there that greater than, what's the probability of obtaining a test statistic greater than
So it
is
should be
0.0403. All right, that's where we have to go back and plug in all the old numbers, right?
Is that group 1, group 2?
Yeah, the one we closed out.
Okay, I've got it up.
Yep, there it is.
Too. All right, let's see.
Definitely adds more flavor.
Copy.
Right, Dad.
paste.
No.
Oh, okay. So it's back up. So the first question we got right at 2.00. So the p-value for one that would be greater than would be 0.344.
How'd you get that?
I plugged in, I replugged in the number A, the chapter A data.
Uh-huh.
Okay, and then I changed the type of test to greater than, and it changed the p-value. So if you leave it at equal, if you left it at equals, not equal to, have I
Uh-huh.
got something wrong here? 95% interval, let's see here. Because now I don't have the 2.00. Okay, I've got something wrong here. Oh, I got N here, okay. In there. 2.2. Hang on. I gotta put my stuff away. Okay. There we go. Alrighty, so yeah, 2 and then not equal to. So if we change it to greater than, because that's what it's asking, right?
Mhm.
Greater than, it changed it to 0.040. So give.
Yeah.
Come back to that one.
What did you ask Connor about it?
He said he could do it, but it take a day or two. He's done it before, he said.
Well, I submitted it again. It looks like I still got 4 and 17 wrong, but I guess I'm fine with the 90%.
17 is
What
still,
would you say tastes better?
wow.
I don't
So it's
get.
not the 11.953?
Better to me.
What's that?
It's not the 11.953?
I had
Um,
11.955. Did you get
Don't put.
11.3?
I got 11.953, but I accidentally hit 55, so I don't know if it's right.
Oh.
But the 11.955 is wrong for 17, so don't put it.
So 11.953 is that was what you got, right?
Yeah, and I it's fractionally off, so who knows if it's right or wrong because they're so close together.
Mm-hmm. All right.
I do not get this at all.
I think
I don't either.
It's getting a little bit difficult compared to what we've
It's
been
just the
doing.
margin of error because it seems to me that we're following the equation exactly.
and
Yeah.
it's coming.
That's what I thought on the last quiz. I just might add in there again. I thought I was following it exactly.
Number 11 was bounce reject. Is that what it was?
Reject
was
the null.
reject-
Reject
It
the
was to
null.
reject it,
Oh,
yeah.
he still rejected the null. That's right. That's why I didn't write it down. And then just trying to put my answers back. Reject the null. There. Yeah, we have 2 reject the nulls in the same one up there. And then 14, which is right.
14 was the third one.
Yeah, not enough.
And not enough information.
Right.
Right. There was not enough information on the other.
And 16, 11.955.
Right.
Yep.
Laughing, but I was trying to hold it back.
17 is a big old question mark still, because I have no clue.
It's not the 11.953.
I didn't put that in. I put in 11.955.
I'll try the 11.953.
Okay.
They can find you down there. What are you doing?
Rubbin, is that what he said? Rubbin?
That's what it was, actually, yes.
Yes, it was actually, yes.
So number 4
Say Rubbin, and I hear
is
down.
the probability to determine the p-value for Jordan's hypothesis test. We're not supposed to find the p-value of greater than his test. We're supposed to find the p-value for his test. I don't know what difference does that mean we do. Not equal to?
Yeah. Jason is a-
See, the probability of obtaining a test statistic greater than Jordan's.
All right.
I would say either
Yeah.
greater than or not equal to, yeah.
Where's
Well, I'm
it?
gonna go and put back in those values for that one.
Good thing it makes some good macaroni and cheese, huh?
Wait a minute.
I think it is.
Wait, did I do the right one?
I tell you, it's a bad way of making it.
Yeah.
Because that would have been data A that we were collecting on there. Oh. Hello.
You use salt and pepper.
It's so mean. This is good to me.
No, it's when you add Parmesan cheese.
Not necessarily.
There was only 20 in that one.
Yeah.
All right, it's 20.
We need to get rid of the summary statistics in the top, correct? When we start running these other ones?
Yeah, I'm getting to where I want to just blank out the whole thing or close the file and reopen it fresh
Right.
so that I don't have anything in it.
Oh, yeah.
Whoa. All right, I know I didn't see something's not right here. Oh, I got an idea.
Hey Jason, did you ever play The Legend of Zelda Breath of the Wind?
Wild.
It's at
No.
the DI. It's at the DI right now.
For what console?
$3.
For what console?
We.
Breath of the Wind?
Is that the new one?
Breath of the Wild is the new.
Breath of the Wild is the newest one.
I've never heard of Breath of the Wind.
I think he's making it up because he misread it.
Because Breath of the Wild is not for the Wii.
It was for the regular Wii.
It's only Wii U
It's not Breath of
and
the
the
Wind.
Nintendo Switch.
I'm getting confidence levels at negative 128 and positive 190. I'm going, what? Did I do that all right from the previous data?
Mhm.
I did not. We have to plug back in that 2.2, 3.3, and the 9. Would that T would we take and plug in on that 0.0403? We wouldn't plug that into that
Chart?
applet.
Yeah, that's what I was just wondering. I got a 3.472 or a minus 3.472 for the T value when I plugged it in the area. That might not have been the right place to put it. Let's try it down here.
We've got that with how many degrees of freedom thing on the T thing, and
So the area is 97, 0.9704 is the area. Yeah, nope, that's not it.
oh, if we plug in a T value of T, and then the area that I show is 0.1476 in the student's T probabilities applet that with 1 degree of freedom. I don't know, that question just totally confuses me.
Yeah,
Basically.
thought I had it. Figured out.
Greater than Jordan's test statistic is 0.0403. So probability determine the p-value for Jordan's hypothesis test. So what should we be doing? Maybe we have to do something with the we have to determine the new p-value.
Is this the sort of thing to determine the p-value for his test? Does that mean, is it just the opposite? Like,
Well,
what am I trying to say?
there's probably a formula, because if we use for differences a standard deviation 3.3, the mean of 2.2, standard error of the mean 1.1, we've got a t-value, the previous p-value, we got our confidence intervals. We want to know greater than his test statistics. So instead of the equal to, do we say greater than?
It doesn't say we want greater than, though. It says the probability to determine, use this probability to determine the p-value for Jordan's hypothesis test, right?
The probability of obtaining a test statistic. A test statistic would be the t, right? Greater test statistic.
Is 0.403, but that is a p-value. So you're using that p-value to determine the p-value for Jordan's hypothesis test.
Well, maybe we plug in that 0.0403 into the t-value. And it gives us an area 0.4872 just going to the right of it. I don't know, I could plug it in and see what happens.
I think we can spend all night on this and not have it.
I feel like it's just got to be the not equal to or less than, but I'm not sure which one. Because I don't think we're actually trying to calculate greater than his.
So in the student's t probabilities, if I plug in that value for the t score,
Yeah,
on that APSAT normal probabilities with t,
yeah.
then the area is 0.4872. So if I put in 0.487, because that'd be on the greater side, I would imagine. If it's I can just throw it in and see what happens.
Wait, what? What are you doing?
So if I take that 0.0403, and we have that t distribution applet that we haven't touched yet.
Yeah.
Right.
The probability.
And if I plug that number into the t distribution applet, would that tell me the area to the right of it?
Yeah.
If you put equal to t?
If you just highlight the right.
Yeah.
No. The 0.0403 would be the area, not the point equal to t.
Right. And then if you put 8 degrees of freedom, because that's what it's showing here is 8 degrees of freedom.
Where do you get 8 degrees of freedom?
On the DF on the bottom. Third sample.
Oh, 8 degrees of freedom. So should we plug in 8 degrees of freedom on that?
I get a 1.999.
For the t.
Yeah, for the T.
So I think that I feel like the p-value is going to be either be just changing it from not equal to, or changing it to either not equal to or greater than, but I don't know which one's the right one.
Well, I guess we're just going to try it then.
Not greater than, I meant less than.
0.080 or 0.81. 0.81.
I have 0.081.
Yeah.
Didn't we try that before?
No, we tried 0.0403.
You know, I'm going to submit it at this point. It's fine.
Yeah, I need
I
to.
already did a while ago.
You said it is wrong?
Which one?
I said if it's wrong, it's wrong. And,
Oh, yeah.
you know, we're just going to have to Get help on
We'll have to figure it out later, huh?
Well,
Yeah.
my second time around, I got a 90 and I'm
0.081 is correct. So if you set it,
0.081?
yeah, 0.0 number 4. So if you set your thing to not equal to,
Right.
the statistics in the top part, and the p-value was 0.0805. So I did 0.081 and it was right.
nice.
Awesome.
But 17 was still wrong. So 17 is still wrong. We do not apparently know how to do the margin of error. Okay. We need a class on margin of error.
All right, I'll get mine submitted, and I'll probably get the same 17 wrong.
Oh, that's hard.
Yeah, it was not a fun one tonight.
No.
No. Yeah, I still have 17 wrong too.
No. All right.
All right. So if we need to meet earlier on Thursday, I would be available earlier. But it'd be afternoon or after 1 o'clock,
Yeah, I'm working.
after probably 1:30.
Yeah.
Otherwise, I'll talk to you guys on the road.
Yeah.
Yeah, I won't be available until. Well, let's see, Thursday. I'm available probably anytime after 4:30. No, 5:30.
Or do we want to do Wednesday this week?
I'm not really.
He's tied
Yeah, I
up on
won't be able to make
Not
it
really.
Wednesday.
Thursday?
it.
All right.
Yeah, I work until 4:30.
I'll see.
5:30 your time. So.
Okay. So we'll just plan on normal time, and I will see if I can get in and try to get some things figured out ahead of time and see where we agree on when we all get on the phone.
Okay.
Yeah, you can always call my cell phone. I can put you on speaker.
Do that too.
I can send you my phone number.
All right, sweet.
Okay.
And I will get this video posted so our teacher can watch it and help us.
Yeah.
See how lost we
Right.
were. All right. Thank you, Air.
Here,
Thank you, guys.
Maria, hang
No
on.
problem. Thanks, everyone.
Okay.
Hold on. I'm going to hold something up for you to see, Maria. If you
All
can't
right.
connect up, call my cell phone. There we go.
Last 2 digits.
9395.
Got it. Got it.
Okay. What's your area?